Okay, here's number 44. It's a piecewise function, and the directions say to tell any places where it's discontinuous. And when you want to do that type of question for piecewise, the first thing you do is check each piece separately. So like, for example, I look right here. I say right here I basically have y equals negative 2x. That's a line. That's continuous by itself. And my other piece is a parabola. It's a quadratic, which is also continuous. So the only place this function might even not be continuous is right where they meet or don't meet at x equals 2. So the way we did it, the technical way to do it is using limits, but kind of the shortcut way is just take that number 2, plug it into both equations. If you get the same number, it meets at the same place and it's continuous. If you get a different number, it doesn't. So if I plug 2 into the top equation, I have negative 2 times 2, which is 4. And if I plug 2 into the bottom equation, I have 2 squared minus 4 times 2 plus 1. And that would be 4 minus 8 plus 1. That would be negative 3. So it's definitely not continuous. And the answer to the question is it's not continuous, or you could say discontinuous, at x equals 2. It is continuous everywhere else. Okay, for number 50, a slightly different question. It says we have this piecewise function again, but this time you have this extra variable a right here. And it says you're supposed to find a so that the function is continuous. Well, I'm going to start the question the same way that I did the other one. I'm going to say if this thing is continuous, then if I take this value, x equals 1, and plug it into both equations for x, I should get the same number. So if I plug it into the first equation, I have 3 times 1 squared. 3 times 1 would be 3. And if I plug it into the other equation, I have a times 1 plus 5, which would be a plus 5. Now, if this thing is continuous, then these two things here have to be equal. So what you want to do is take those two things, set them equal to each other, and solve for a. And it's very simple solving from here. So basically just subtract 5. And a ends up equaling negative 2. So if a is negative 2 in this problem, then the functions are continuous, or the function is continuous. If a is any other number, it's not continuous.